Problem, all we're looking at is what forces are present when we do the assigned task. So for here, we're melting ice. So what are we doing when we're melting ice? We're changing it from a solid to a liquid. When we're changing just the state of the compound, that's just an intermolecular force. So therefore, we have to look what the substance is. And the substance is water. So H2O. So we know that most compounds have dispersion forces. Actually, between all atoms and compounds, there will be dispersion forces. So we know it's a given that there will be a dispersion force. However, H2O, it's O's electronegative, and also not only is it electronegative, it's a hydrogen bonded to an O, to an oxygen. Therefore, it'll be a hydrogen bond too. So it'll be a dispersion. I'll abbreviate. This will be a dispersion force, and it'll also be a hydrogen bond, which is a type of dipole-dipole bond. It's a hydrogen bond is a type of dipole-dipole bond. So when we melt ice, we need to overcome dispersion forces and hydrogen bonds because we're changing it from the solid state to the liquid. Next, boil molecular bromine. So what are we doing when we're boiling something? When we boil something, we're changing it from the liquid to a gas. And now what is the substance? Molecular bromine. So bromine is a diatomic, Br2. So what does that tell us? Br2, so Br will have the same electronegativity. So since that's the case, it'll be nonpolar. And since it's nonpolar, it'll just be dispersion. Because to be a dipole-dipole, it has to be polar. So next, melt solid iodine. So what are we doing? So melting a solid. We're changing it from the solid to a liquid state. So now what's the substance? Iodine. So iodine is also a diatomic. It's I2. Therefore, when we melt it, we're overcoming intermolecular forces. So we know it's a given that we're overcoming dispersion forces. But is it polar? No, because it's a diatomic. It's the same element. Since it's the same element, it has the same electronegativity. Therefore, there will only be dispersion forces. Finally, when we dissociate F2 into F atoms. So when we dissociate F2, what are we doing? When we dissociate F2, so we're actually not changing the state. These were we were changing the state. Now we're actually breaking down the molecule itself. So here we're just changing the state. We're not doing anything to the actual H2O. We're just like for example, the first one, right? H2O is just bonded to another H2O. That's why it's a solid. So what we're doing is we're breaking the bond between H2Os so then it can move more freely and become a liquid. Here we're actually breaking down F2 into its components. Therefore, this isn't an intermolecular force. This is an intramolecular force. It's within the molecule. So let's look at the actual thing. Is it ionic or covalent bond? F2 is actually a covalent bond because it's nonpolar. It's a nonmetal. See, if it was an ionic bond, it would be between a metal and a nonmetal. But this is just between it's between two nonmetals. Therefore, what we're actually doing is we're breaking covalent bonds. Because it wouldn't be any of the intermolecular forces because we're not breaking down like F2 and F2, we're breaking down the actual F2 into F atoms. So those are the forces that you'll need to accomplish each of those tasks.